Liberty and justice for all. No, liberty and justice for all.
This is lesson number 2. In lesson number 2, we'll look at multiplication and also introduce the concept of division. As usual, I like to ask the question, what is? What is multiplication? Now, hopefully, you know how to multiply. That's the assumption I'm making here, that people who are watching this tape, whether you are an elementary school age student or an adult or something in between, you know how to multiply. But what is multiplication? And hopefully, in your mind, what multiplication is repeated addition. In fact, I am told, I was not there, that in ancient Egypt, before multiplication was discovered, that every time a problem that we would do by multiplication had to be done by addition, they'd write the answer down and put it on a brick or on a scroll and keep it in a library because there was so much work to do these problems. And in fact, then someone created multiplication. Multiplication is repeated addition. For example, in our first visual, we see that 6 times 8 means 8 plus 8 plus 8 plus 8 plus 8 plus 8. 6 eighths added. And of course, the answer is 48. Once you learn to multiply, you basically forget this and just simply remember your facts. But it's always a good idea to go back to understand what multiplication is. As again, we get to fractions, decimals, even to algebra, understanding what multiplication is can be very helpful. Notice, multiplication is not counting. It's one step above. Addition and subtraction were counting. Multiplication is now something different. It's repeated addition. It is not counting. The rules are different. Another way to conceive of multiplication is by looking at, for example, the next visual, which shows you a physical representation of numbers that multiply to be 12. Here we have 3 rows of 4. That is, 3 times 4 is 12. Notice if you turn your head sideways, you might see 4 rows of 3. 4 times 3 is the same as 3 times 4. That's 12. The next visual gives an alternate approach to multiplication of 2 numbers, giving an answer of 12. 2 rows of 6, or if you like, 6 columns of 2, so that 2 times 6, or 6 times 2, is 12. And the next visual gives a third way to multiply 2 numbers to get 12. 1 times 12, or 12 times 1. Now, let's take a look at a somewhat special number. The number is 9. In our first visual, we see that we have 1 times 9. 1 row of 9. We also could look at it as 3 rows of 3. This is very special. Every one of the arrangements so far has been rectangular. That is, with 12, 3 rows of 4, 2 rows of 6. But this is more than a rectangle. This is a square. 3 rows of 3. And in fact, you turn it sideways, you still have 3 rows of 3. And in fact, 9 is called a square number because one of the ways to multiply it looks like a square. This will become even more important in future lessons. But right now, let's just recognize that these rectangular arrays, these rectangular groupings of physical things, show us what multiplication truly means. Now, a question I always like to ask involves the next visual. We're multiplying 38 times 247. Now, at this point in time, I'm not going to ask you to multiply. I'm just going to say, look at the 2 and the 3. They are connected. Where, let's see, 2 times 3 is 6. Where does that 6 go? In what place value? So stop the tape and decide where the 6 goes and justify your answer. Well, a lot of people would try to do that by actually multiplying the entire problem. No. We have 2 times 3, or 3 times 2 is 6. But notice that 2 is in the hundreds place. 2 hundreds. The 3 is in the tens place. And I multiply 3 tens times 2 hundreds. I multiply the digit times the digit. 3 times 2 is 6. But I've also multiplied the place value times the place value. And tens times hundreds is thousands. So the 6 must go in the thousands place. Not because we did it by rote, but because we understand when we multiply, and this is true for fractions and decimals, and any time we multiply digit times digit and place value times place value. That is how we multiply. Now,
Very nice.
most of you, like I said, I'm assuming know how to multiply, but I'm going to show you a new method, an alternate method of multiplication. Now, if you like your own method, the old-fashioned way, that's fine. But I think this method, called the lattice multiplication method, is really good. And the reason it's good is because it involves no carrying or renaming when you're multiplying. It's excellent if you have no calculator because there's no limit to the size problem you can do. And of course, it's very useful in multiplying multi-digit as 2, 3, 4-digit numbers. So let's go to the whiteboard and see how to set up this thing called a lattice. And basically a lattice is just a rectangle that allows us to multiply, and I believe is a much more efficient way of multiplication. Okay? Basically what we're going to do is we are going to first make a rectangle. And since we're multiplying a 2-digit number by a 3-digit number, we'll divide the rectangle into 3 columns for the 3-digit number and into 2 rows for the 2-digit number. And then we'll connect each of the corners in the smaller rectangles to its opposite. Now, it's very important to go through. In case you don't need to make a little curvy, that's okay. It needn't be straight, but it must go from corner to corner to corner and out the bottom.
I'm going to pause this for just a minute to help you with the visualization. Come here for a second, Sarah. Turn around. All right, we were talking about place values. Show me where